We were looking for all these days the difference amplifier, we have looked into the response, we also looked into feedback. The first and the foremost circuit, integrated circuit which is available in market for use of amplification is called operational amplifier, and a typical circuit which shown here, there are of course the normal OPAMP has 3 stages, but in designing we also have what we call 2-stage OPAMP. Essentially a 2-stage OPAMP is a OPAMP without buffers or the output circuits. Okay. So there are 2 stages, the first stage of course is the very high gain stage because of the DFAM, followed by a high swing relatively lower gain stage which is the second stage of the OPAMP, and third of course is the buffer stage which drives the output. Typical number of transistors required to create an OPAMP is typically 22 and may extend a bit here and there up to 30. Okay. So it is not a small one transistor circuit, it has a large number of transistors. Even for 2-stage OPAMP the number of transistors shown to you here are of course the transistor related to ISS has not been shown, which may be more than 2, that is 3, one coming from mirrors for example. So you keep adding such transistors, you will find as many as 30 transistors or at least 22 transistors are required to create an operational amplifier. The 2-stage essentially says you have a DFAM. There are 2 kinds of 2-stage OPAMP, one is the 2 outputs VO1 and VO2, the other is this is called double-ended output, and the second part which is shown here on the right is called single-ended 2-stage OPAMP. Single-ended means output is only one Vout. Okay. Now one can see from here of course there can be different loads. Okay. It can be mirrored loads or it can be constant current sources as shown here. Different loads can be given to DFAM as we did earlier. So there is nothing big about that. Right now I assume they are current sources. Okay. With a, whenever there is a current source, what is the output resistance of that transistor? Always R0. Okay. In which case it is not R0 or R0 parallel something like diode connection shown in the next stage, then it will be 1 upon GM parallel R0s. Okay. Whenever there is a diode connection, we have proved n times that whenever there is a diode connections you will get 1 upon GM shunting R0 and essentially it may be 1 upon GM itself. Okay. Okay, so here is as I said the output of the first 2 outputs of a DFAM are given to a 2 amplifiers, one on the left, one on the right. What kind of amplifier do you see this? This is a P channel device. So input is P channel input, device is not N channel which is receiving input. Okay. And what is the load for that? For example for M5, M7 is acting like a load which can be a current mirrored load or any other load which you can create there. Is that clear? Now this means which kind of amplifier it will be? Single stage, source is here. So where common source amplifier, this is a normal common source amplifier with P driver, is that correct? With P driver, so not much different between analysis of N channel drivers or P channel drivers, is that correct? In CMOS normally what we do, we have N channel drivers with a P channel loads. Here we have a P channel driver with N channel loads. Okay. So whatever gain of DFAM, see VO1 will be proportional to Vins, okay, which is then given to the input of the next common source stage which will have some gain A2. Okay. So what will be the net gain at the VO2 or VO1, Vout1, Vout2? If A1 is the gain of DFAM and A2 is the gain of the output stages, then the net gain is A1 into A2. That is what we essentially do in a 2-stage OPAMP. So will this gain be then much higher? What is typically gain of a DFAM do you expect? What is typical gain of a DFAM? GM times RO1 parallel RO2 or RO3 parallel RO4. ROs are typically order of mega ohms, is that correct? Typically order of mega ohms. GMs will be order of at least 10 to the power minus 3 or in between minus 3 minus 4 amps per volt. Okay. So typical value will get gains of around 1000 or 5000 kind of things can be achieved through only DFAM, is that correct? The gains of a DFAMs can be as high as 10 to the power 4, okay, or even higher sometimes, depend on the GM values you choose. RO's value, on what these depend on? GM and RO's? Both it is depend on the ISS, is that correct? So choose your ISS to get the possible gain values. Okay. Now once you decide that DFAM has this much gain and you have another gain stage which may have again GM times parallel RO of this, okay, and you adjust if the currents are same for all the transistors, one can still get some amount of gains, maybe 10 to 100. So typical OPAMP may have a gain of how much? 10 to the power 4 to 10 to the power 5. Typical OPAMP will have gain stage, gain outputs of the order of 10 to the power 4 or 10 to the power 5, okay, or maybe in best design may be even higher, but it may have some other problems if we gain too much gains on that. Okay. So is that point clear? So OPAMPs are no different from amplifiers which we have already designed, already seen how they are solved. Okay. This is the second part of this circuit is, this is called single ended output, and what kind of loads we are using here? Mirror loads, okay, mirror loads. ISS, bias current, 2 beta dash W by L into ISS, under root of that is GM, 1 upon lambda ISS is the ROs of that. So one can evaluate what GM, remember IS increase and IS decrease will have opposite effect on GM and RO. So you may get reasonable gain. If you still want higher, make sizes double, increase W by L, okay. That is the way gains are adjusted, okay. Okay, I will give expression, I have written down those expressions, but before those I just thought what I am doing. I showed you this is my standard DFAM with the current mirror loads. This is my input between 1 and 2 terminal is my Vin. This may be coming from the current source, this may be your standard M5 or M7 number earlier we gave, and this is your common source output stage, okay. Please remember again this has a P channel device which is receiving signal, output of the first DFAM is given as the input to the common source amplifier with P channel drivers and N channel loads, okay, N channel loads. So if we now calculate, here are some expression which you do not have to think too much, I just wrote down without you were seeing. For the DFAM, for this DFAM first VO1 and VO2 will be GM1 RO1 parallel RO3 into Vin, VO2 will be minus GM2 RO2 parallel RO2 into Vn. If GMs are equal, ROs are equal, they will be correspondingly GM RO terms will appear. Then what is Vout? Vout is the output of, Vout1 is the output of VO1 as the input, and that is GM of 5 into RO's parallel combination of 5 and 7. So that is what I did, GM5 RO5 into RO7 parallel RO7 into VO1, substitute VO1 from here, so you get GM1 GM5 RO5 parallel RO7 RO1 parallel RO3 into Vn. So the gain is Vout1 by, and by same it will be Vout2, it will be same if GMs are same, Vout by Vn. So these are the two voltage gains. Please remember GMs are getting multiplied, so our R0s are getting multiplied. So essentially A1, A2, the two gains we are multiplying, is that correct? This into one, this into this, and this into this is A1, A2. Is that clear? GM5 into this is A2 gain, GM1 into RO1 parallel RO3 is the A1 gain. So A1 into A2 is the net gain of a two stage OPAMP. Is that clear? First stage has a DFAM has a gain stage of A1 which is GM1 RO1 parallel RO3. The second stage has a gain GM5 into RO5 RO7. So that is multiplied to the first stage gain. So A1 into A2 is A final. Is that okay? So without even evaluating all of it as we did equivalent circuit, we can directly write these expressions. Why? How can we write these directly? Because we have derived all of them individually every case. So in future we do not have to keep deriving everything, we say okay for this is what it is. But if someone said derive AB initio, please go back, write equivalent circuit and solve all of it, okay. But generally I mean for solving these we do not need that. In the case of single ended, what will change? Nothing much will change. GM5, just look at this, the output will be GM5 times parallel combination of 5 ROs of 5 and 6 and into whatever output coming here, which is nothing but same as what we did earlier, GM1 into RO2 parallel RO4 into GM2 RO, it is still the same, only thing is it is single ended on the one side. And what is the advantage there? Advantage there everything can be mirrored now from everywhere, we do not have to put any current sources directly, is that correct? Because mirror, why I say mirrors are easier to create, because once you create a mirror source, current source, you can always mirror any number of places. How do I pass on that? Gate of that should get to the gate of that with a diode connection on the one side, so it will just replicate the currents in the next stage, and if you change the size you can increase the double or triple or any number of amount of current can be pushed to the other side. So it is much easier to control the currents and therefore the outputs by just using the good current source as my one current source I create and that I mirror everywhere wherever I want additional currents, is that clear? Now the only thing is if p channel mirror has to be, what should I do? I last time gave an example this, from n channel first you will have go to a p channel, the output of a second stage should be a p channel load mirror which then can be connected to the next p channels, is that point clear to you? There was an example given to you, first create an n channel mirror, then the second part transistors, this output or drain should be taken to the drain of p channel which is mirrored to the next stage by again connecting source and drain and gate, keep then going to p channels, and if you want back n channel, what do? Bring that to the next n stage at the output and mirror it again for the n. So how do we go from n to p transfer, p to n transfer, so any number of times any stages I can keep transferring the current to n channel to p channel which may be ratio of W by L's which I can create, is that clear? That is the trick which we all follow. So we do not actually use current sources normally. Why we do not do it? Because internally putting another bias is difficult. You know VB you said, normally how do we get that current source? I need some bias potentials here. This may not be same as VDD. In that case I may have to put too many voltage sources inside, that means connection from the pin, so many pin connections should get in for putting voltage current sources creation. So we normally put one VDD, create a current source, okay, and then replicate everywhere whatever bias currents you need, is that clear to you? This is the trick we follow, because otherwise on a board we do not mind, there are power supply, 2 power supply ले लेंगे, 4 pins ले वहाँ से connect कर, but in chip, what is the importance of a chip compared to board? What I said, so many transistors I want to put in a smaller area, that is the integration I am looking. If I put additional voltage line somewhere, I will have to leave some space for it, that means I am not using that space for transistor. So the trick in integrated circuit is avoid any extra lines if you can, if you do not, I mean if you need it, nothing else can be done, is that clear? So this is just to give a out why I normally use current sources and not so much normally current mirrored loads, or this is just to that, but in reality on a board I can put all kinds of loads, resistive loads, current source, diode connect, all can connect physically anything and get any outputs. So the theory was shown to you what purpose, what are the advantage, disadvantage of any kinds, and if it is a discrete device you can use most of it, okay. But in integrated circuit the first major thing we do is to avoid areas giving, not doing any any transistor there. If transistor area is taken by something else, I say forget it, okay. That is what ICs are slightly different from normal discrete transistor circuits, okay. No difference basically in performance, only thing why do we some things, okay. So yes, no, but on the like in this case I want the current to be taken from somewhere, where from I get p channel currents. So the gate of this must come from a p channel site. If I want a current on this be fixed by me, let us say I want, so this p channel gate cannot be connected to n channel gates, so they must be connected to p channel gates. Now p channel gate must be mirroring from other p channel device whose drain current must be the drain current of n channel mirror. Okay, so you create only n channel mirror, but pass on to p channel on the top and then move to p channel. When you want again n channel, come down, create to n channel driver and go back, keep doing any number of times. So हमेशा देखो n channel, p channel, n channel, p channel. Is that clear? Flip, ऐसा ही जाएंगे हमेशा. Okay. So this essentially what I was trying to say. I may not do details about this OPAMP basic internal circuit. As I said, the 3-stage OPAMP, which is the real OPAMP, has the gain stage, the single common source gain stage, high gain stage, common source gain stage, followed by another circuit which is called buffer, which is essentially for large driving of the output loads. To drive loads, larger loads, we need larger currents, and since we need larger current, buffers are ones which provide larger currents. Is that correct? Buffer provides. If you want larger current, what will be their W by Ls of transistors for larger currents? Larger or smaller? If I want larger current, transistor sizes should be larger or smaller? Larger. Larger W by L and larger current, will that lead to smaller output resistance of that transistor? 1 upon I, is that clear? So the larger the current, R0 becomes smaller, is that point clear? So all OPAMPs have very low output resistance because of the buffer stages we keep there, okay. However, if you look at the input resistance, can you tell me the input resistance of this OPAMP is higher or lower, either of them? Please look at it, there is a gate connection which is insulated from source drain. So the input resistance of a MOS transistor is practically infinite, but at least 10 to the power hundreds of mega ohms or at least tens of mega ohm and above. Is that clear? Let us say it is a bipolar transistor, will still be Ri will be higher, their base collector base emitter junction is connected there, so is still higher? Yeah, it will be very relatively high. Why? The resistance of source, which will be Re or whatever we call, that is emitter resistor. How much impedance it will see at the input side on the base? Beta plus 1 times Re itself is 10 to the power 5 or 6, okay. So 100 times that. So in either case OPAMP has large input resistances, is that point clear? Whether it is bipolar or MOS intrinsically gives because it is a MOS, but even in bipolar because of Re your input resistance is extremely high, and that is the property of a OPAMP. What is the property of OPAMP? The input resistance of an OPAMP is very high, output resistance relatively is very small. It is not RO of the transistor, it is the output resistance seen is very low compared to any other resistor on the chip. Is that clear? This is the feature of an OPAMP. What is the feature of an OPAMP? Large gains, large input resistance and small output resistance. Is that correct? This is the property of a OPAMP. Okay, just for the heck of it, there is a OPAMP which is also is an OPAMP, but it is not called OPAMP, it is called operational transistor transconductance amplifier, called OTA. जरा सोचो कि ऐसा क्यों नाम दिया मैंने, ऑपरेशनल. अभी ये नॉर्मली तो ये वोल्टेज OPAMPs are voltage amplifiers. So there is a operational transconductance amplifier, or very popularly named as OTA, okay. So please remember, OTAs are normally used in what we call GMC filters. GM means transconductance, C is the capacitance. These are continuous filters which are called, what is continuous, what is the other kind of filters? Could be digital filters, okay, which are not continuous filters. So GMC filters are essentially continuous analog filters which can be created by a few capacitances and an OTA, okay. We will see that little later. So is the issue clear? What is the advantage of op-amp over normal amplifiers? Normal amplifiers, unless its emitter follower, its input impedance is very low. How much? As low as few kilo ohms, okay. HIB or RE is hardly QI by KT, okay. So that resistance is KT by QI. So that is very small, so few kilo ohms, okay, and now few kilo ohms is not what we are looking for, okay. So normal amplifier to op-amp, his first thing we achieved is very high input resistance and comparatively much lower output resistance. Is that clear? That is the feature, and the gain is very high, 10 to the power 4 or 10 to the power 5 will be the only thing is this gain should be called open loop gain. What does that mean? No feedback is right now available, so from output to input there is no feedback connections. So the open loop gain is 10 to the power 4, 5, maybe higher than 5 sometimes. Is that correct? These are the features which we are looking into a operational amplifier. Okay. Some of the characteristics which you all have done in the lab, hopefully I will just list them. The few things which is of interest in knowing the characteristic of op-amp is, the first and the foremost worry is the input offset voltage, okay. Now what is the term we are talking? So if you have an op-amp maybe which is a symbolized something like this, plus minus, V in 1, V in 2 are given names V in this. So if you have V in 1 and V in 2 and this is V0, we say in DFAM first stage, if both inputs are 0, output should be 0 because no current, output should be 0. Is that clear? And output of an op-amp is, if GM is 0, output is 0, okay. Currents are 0 there. But if we actually see inputs 0 and still we see some output, in real life what happens, that we thought that when V in 1 is made V in 2 equal to 0, output should have gone to 0, but in real life if I monitor, even if I see some voltage at the output, okay, that means the V0 V in characteristics is something like this. Even when the V in is 0 here, there is an output voltage. Is that correct? There is an output voltage. So the difference between when the V in is 0 or V in is V out is 0 to where V in is 0, this difference is called input offset voltage. Where should have been normally it should have crossed 0, it should have crossed from 0, it did not cross, it crossed from the left, so it required it, when I went to V in I found some outputs, okay. Now this occurs, essentially we say this occurs because of the mismatch of the transistors, okay. There what can be mismatches? There can be size mismatch, there can be what else? Size is W and L mismatch, what else can? VTs can mismatch, okay. So if there are mismatches in the two transistors M1 and M2 or M3 and M4, then ideally we were expecting difference between them to be 0, which may not occur because one of them is not giving same outputs. Is that correct? So there is some finite output potential you may see. So how do I get rid of that? Let us say it is plus and minus. If there is an offset here, I should put in this or this plus arm some opposite offset voltage here, which will actually cancel the other terminal offset on that. Is that clear? Let us say offset is plus 10 millivolts, so I apply minus 10 millivolt at the input, so 10 minus 10 is 0. So always see in your op-amp there is additional terminal given to you for offset cancellations. All that we do to put a resistive network with a power supply, keep varying that pot, so that offset goes to output goes to 0. Is that correct? V plus you put a divider and change the voltage or change the resistance, okay. See that when V0 goes to output is 0, we say offset is cancelled. but in real life offset may be present. Okay. Of course, we will not look into this. There are two kinds of offset. Which can be two kinds? Any random, this is one of them can be random offset, okay. The other can be systematic offsets. So it is much easier to cancel systematic offset, because what is I am trying to say, oh every time it moves there I will actually put minus there as if it comes to 0, okay, but sometimes goes there and sometimes goes there. How do I do it? So random offset, which is essentially noise related, they cannot be cancelled, but systematic offsets can always be cancelled. Is that correct? Is that point clear? So one problem which you can see by this, the worst case offset could be VDD by the gain or VSS by up the gain, because that is the highest voltage, output divided by gain is the input. So the plus or minus offset could be achieved, the highest will be VDD will be maximum output, or VSS minus VSS will be maximum lower side in output. So divided by the gain is the possible maximum offsets possible. Is that correct? This is the maximum possible outputs it can swing, divided by gain will be the maximum minimum offset voltages. Okay. Cannot be, because output cannot rise beyond VDD. So VDD by AOL is the highest offset you can get, whatever reasons, because you are now saturating. There is no AOL, beyond that AOL does not exist in fact. AOL is 0 then. Once VDD reach, AOL does not exist. If at this point there is no gain. Okay. So the maximum possible is VDD or VSS. Okay. The second term of interest, second worry of all of us is to get CMRR as high as possible, which is 20 log AD difference gain by common mode gain. If your mismatch occurs, which is the first cause, will also lead to CMRR, because then ACM will not be 0 but will be some finite quantity, that is GMs are not equal. Actually if you see the term, it is GM1 minus GM2 occurs. So if they are equal, so it becomes 0. If they are not equal, then there will be a finite quantity will occur and ACM will be present, then CMRR will be there, which is typically what is the minimum CMRR I suggested you, 80 dB. There are OPAMPs, I think some of the 725, 723 or these OPAMPs may have a CMRR of 70 dB, but they are gaining something else. Look at that some sheets and you see why they reduced the CMRR. Okay. Okay. All 741s are always greater than 80 dB, and typically the highest of 506, 80, 506 will have a CMRR of around 120 dBs. Third interesting parameter for is power dissipation. Please remember, last time when I calculated there may be some this I did not show you correctly. Power dissipation is something like this. VDD minus VSS the maximum voltage available to you. Is that correct? So when the current goes from here to VSS, the maximum voltage swing is VDD minus VSS. But there are too many currents flowing. One is of course this, other is because of this, then there is a mirror currents. Okay. All vertical branches current going from VDD to VSS are paralleled. Is that correct? VDD to ground, VDD to ground, VDD. So add all those currents because they are supplied by same VDD and received at the same VSS. So the power dissipation of an OPAMP is all vertical path currents multiplied by VDD minus VSS. That is the power dissipation of an OPAMP. Is that point clear? Current in this path, current in this path, of course this together is in this path and mirror whatever or any other hardware which is like buffer output to ground. Any current path going from power supply to the ground, that current should be added to all other currents parallelly going through because they are drawn from the same power supply reach to same VSS. So VDD minus VSS, this is plus of course because it will add minus of minus VSS. So let us say 2.5 minus 2.5 means 5-fold multiplied by the net currents is the power dissipation of the OPAMP circuit. Is that correct? The fourth quantity of interest is called PSRR. Now this is also very important. There is a lot of research can be done on this, but let us see only as a characteristic now. This is one of the major design parameters for OPAMP, but right now we will not look too into this. Let us say the VDD and VSS are not constant, which can occur. Why it can occur, do you know? Why VDD may not remain VDD 5 volts or 2.5 volts, it may become 2.5 plus minus something. Same way VSS can become plus minus something, okay. Essentially say some noise is overriding on them, okay. And we know VDD will decide the current or VSS will decide the current, DC currents. So what it will change then? All AC parameters are affected by the DC currents, bias currents, is that correct? GM is proportional to root I, lambda is 1 upon lambda I is RO. So you see any parameter, any DC thing change, the AC parameters are varying, therefore gains may vary, is that correct? So we want how much we should tolerate the variation in power supplies this, so that gain remains within the acceptable limits. Why we say acceptable limits? Let us say I am getting a gain of 1000. So I say if it is 995 it does not matter, if it is 1005 it does not matter. But let us say I have a gain of 10, then I cannot say gain of 5 and 15 are same as 10, is that clear? So the amount of tolerance at the gain stage output gain you are looking for, within that range the variation in power supplies be allowed, is that correct? As long as you are within that, you may say it is fine, okay. This is called, so what we are expecting, how much is that tolerance allowed, so that the output stage gain is not very much varying, acceptable limit. So we define EOL is the open loop gain divided by V out plus V plus, because of this ratio whatever is the change occurring is decided by power supply RR plus. Why plus? Because it is on the VDD. By same logic PSRR minus is AOL divided. You can see what is this essentially I am talking, variation in output due to variation in VDD or VSS. These values are essentially called power supply. How do you really remove this much of the PSRR problems? You have done already the lab experiment on this. If I want to see that VDD does not change very much, but it may officially I do not want it but may occur, then how do I remove that? What do I do at the output? You must have seen, and if you have not seen please see it now. This is your VDD terminal, I actually put a capacitor there, is that correct, which filters out those frequency components which changes the VDD, is that correct? Have you seen any time or you are never connected? All power supplies should be connected through a bypass capacitors to minimize the variation in VDD and VSS, which will improve your PSRR values, okay, is that clear? So we do not really do great things in VSRR outside internally. Internally we can do lot of things, but for external people also still you have a choice to put a capacitor. But what is the problem with capacitor? Because it is only some frequency it will remove, is that correct? Because it is a low pass filter, so it will cut some of them, okay. Depends on different frequency which you are going to get, you may require n capacitor which will be very difficult to put. So it is not that, so 50 hertz certainly hum which is called will be easily removed, okay. Maybe 100 hertz can be removed, few kilohertz can, but if it is a megahertz noise nothing can, it will pass in fact. So that is the problem in, so PSRR is not just for these, it can also for any other noise, and therefore internally we do design to improve PSRRs, is that correct? So do not think that a capacitor से सब problem solve होगा, ऐसा नहीं है, okay. Now the next value for us which we already discussed is the slew rate. What is the slew rate definition we gave last time? That how fast the output responds to input, okay. So it is dV by dt is the rise of output to its maximum value, which is essentially I said last time it is ISS divided by the load capacitance, okay. So this is also last time I already given you example in which showing one of the way the current ISS is fixed is requirement from slew rate, requirement from power and requirement from the gain. So all three should somehow get matched to everyone's requirement. Okay. So this is essentially, there are few more characteristics, but these are essential characteristics which all must be knowing prior to we start working on OPAMP in a lab. Okay. Now here is something, the first, though we are in our course this is, but just to get to what he has taught and little differently from what he has taught. You know why I say, because I always want to show you little different from what others showed you. Okay. Here is something what others, this is a OPAMP. My ideal assumptions are RIs are very high because of this is a basically I am looking for MOSFET MOSFET OPAMP. There is an input source which has an R1 as the series resistance there. From the, I define for OPAMP two terminals, one called inverting terminal, the other is called non-inverting terminal. It has nothing to do with minus and plus per se. The idea is if I put input here, the output gets inverted to the input. If I put input here, output does not get inverted, and therefore these names are given minus and plus. Okay. They are essentially Vin1 and Vin2 of a diff amp. Okay. In most non-inverting amplifier, inverting or not, this is inverting amplifier, the V plus terminal is grounded. Okay. Which means Vin now occurs between V minus and V plus. Okay. So here is the ground. From the V minus terminal, I connect a resistance R2 to the, I will not solve this problem directly, but can you think which kind of feedback circuit is this? Output को यदि जीरो किया तो क्या फीडबैक आएगा क्या? नहीं आएगा ना, V0 जीरो किया तो there is no R2 में कुछ नहीं होगा फिर, है ना, वो जीरो हो गया उसके ऊपर. What does that mean? What is being sampled? Voltage has been sampled. So what is the kind of voltage sampling? Shunt sampling, is that correct? At this node, what is being summed up essentially? Currents. So what is the sampling mixing? Shunt mixing. So this is shunt amplifier, is that correct? अभी थोड़ा सा सोचो कि shunt amplifier में gains कैसे बनते हैं. So इसका भी AOL निकाला जा सकता है, बीटा निकाला जा सकता है, और AOL upon 1 upon AOL बीटा, और आप वेरीफाई करके देखो, जो मैं नहीं कर रहा हूँ, कि क्या मेरे फीडबैक थ्योरी से आया हुआ गेन नॉर्मल सॉल्विंग से भी आता है क्या. यदि आता है तो हमारी फीडबैक थ्योरी भी सही है और हमारा ये भी सही है. इज दैट ओके? दिस इज द ट्रिक. आई डिड नॉट वांट टू शो यू, बट आई थॉट यू शुड सी इट्स ए फीडबैक सर्किट सिटिंग राइट हियर. ओके, दिस इज नो कनेक्शन. प्लीज ये जो इधर गलती से कनेक्शन दिख रहा है वो नहीं है. ओके, सो इक्विवेलेंट सर्किट ऑफ ए, दिस इज equivalent circuit of a OPAMP is something like this. Ri, a current source if you wish, across there is a resistance R0, and this is your Ri is tends to infinity in case of VGS, in case of MOS transistors. This is GM VGS, this source, this current going down. Okay, this is your drain, this is your gate, this is your source. Okay. This is equivalent of that, is that correct? So we are saying GM V1, which is VGS for us, is equal to GM V1 shunted by R0, which is the output resistance of the amplifier, and a feedback resistance of R2 connecting between gate and drain, equivalently same. So if I solve this, Vin minus V, this is V1 voltage, Vin minus V1 by R1 is this current IR1, is that correct? There is no current here, so where can current go? Only in R2. So this current R2 is essentially V1 minus V0 divided by R2. So V1 minus V0 by R2. So Vin1 by R1 plus V0 by R2 is Vin again, oh V1 sorry, V1 1 upon R1 plus 1 upon R2, is that correct? इसको सिर्फ ओपन किया है और कुछ नहीं. ये करंट और ये करंट सेम होना चाहिए because there is no current here. okay. So whatever current is coming must be going through R2, so IR2 must be same as IR1, because what is the condition I put? Ri is infinite. If there is a finite Ri, some current can flow, okay, then we may have to do little more calculations, okay. From the KCL you can see from here this equivalent, the current V1 minus V0 is going where? Assuming R0 right now is infinite for the sake of simplicity, where this current will be going? What is that equivalent current? Current GMV1. ये देखो यहाँ से शुरू हुआ करंट, कहाँ पाथ है इसको, ऐसा जाके यही पाथ है, ये करंट और ये करंट सेम होना चाहिए, एक ही पाथ है, एक लूप में एक ही करंट होगा, एक लूप में यहाँ से शुरू होने वाला करंट ग्राउंड में जाने के लिए ऐसा ही जा सकता है, इज दैट करेक्ट? सो GMV1 must be, sorry, GMV1 must be equal to V1 minus V0 by R2. So I collect V1 terms, V1 is into 1 upon R2 minus GM, sorry this cancel, minus GM is equal to V0 by R2. From here I calculate V1. Why I am showing you all this? I am trying to prove that that gain, larger gain requirement क्यों आ रहा है, जो हम normally कितना gain देते हैं R2 by R1 minus R2 by R1 बताते हैं, वो क्यों नहीं, किस कंडीशन में वैलिड है, ये कंडीशन आपको दिखा रहे हैं. So the V1 is V0 by R2 1 upon R2 minus GM. वो जो पहला इक्वेशन था आपका, इस इक्वेशन में इस V1 के जगह वो वैल्यू रख दो जो अभी मैंने निकाला. So if I substitute Vn by R1 plus V0 by R2, और ये V1 ये टर्म है into 1 upon R1 plus 1 upon R2, start collecting terms. So I get V0 by Vn is minus R2 by R1, और ये दो न्यूमरेटर और डिनोमिनेटर पे दो बड़ी टर्म्स आ रही है, 1 माइनस 1 अपॉन GMR2 एंड 1 डिवाइडेड बाय 1 प्लस 1 अपॉन GMR2. We normally say in OPAMP the voltage gain is minus R2 by R1, that is what we have been telling people earlier. But I have now derived the expression which is actually this R2 gain is this expression. When this is equal to this, only when GM is tending to infinity, is that correct? Tending to infinity. What does that GM tending to infinity means? What is the gain we are, which gain we are talking tending to infinity? Open loop gain. So if the open loop gain is very high, then GM times that value will be very high, GMs will be very high, and if that is very high, these two terms can be 1 by 1, and then the gain is R2 by R1. So the condition under which this output voltage by input voltage is minus R2 by R1 only exists if AOL is very high. And what is the AOL? I said you typically of a OPAMP stage 10 to the power 5, is that correct? 10 to the power 5. Since the AOL is very high, we can then assume that the output voltage is just minus R2 by R1 times the input voltage. I will show you without doing this also we solve the circuit and we get it, but actually this is the analysis which we should look, under what condition I can assume that R2 by R1 is the gain function, okay. This is very important in understanding, not that this is always be valid in the case of OPAMPs, okay. But to prove that my case is correct, I showed you this is how I explain that things will happen automatically. Okay, here is another parameter of interest to us is the output resistance. क्या बोला था आउटपुट रेजिस्टेंस कितना होना चाहिए, बहुत छोटा होना चाहिए आप बोल रहे थे ना, तो अभी देखो आता है क्या. How do I calculate output resistance of a network? Short input, at the output apply a voltage source, and the current starting from there Vx by Ix is the output resistance, okay. This is my R out, okay. So I say अभी आप नेटवर्क अभी सब कर चुके हैं, is that okay? The current Ix, and again as of now I will say R0 is very high and I am neglecting current through R0, okay. I can put everything there, circuit थोड़ा बड़ा होता है इसलिए मैं छोड़ रहा है अभी. Okay. Where the Ix current is divided into, one path is this and one path is this. Is that correct? यहाँ इस नोड पर एक करंट इधर जा रहा है और एक करंट इधर जा रहा है. So Ix is Gm VGS, okay, and V1 is VGS as I just now said. So Ix is Gm VGS plus Vx, please remember Vx minus 0. Why it is 0? आपने ग्राउंड किया ना ये टर्मिनल को, V in 0 किया. So Vx minus 0 divided by R1 plus R2, दो रेजिस्टेंस ये हैं सीरीज में, ये वोल्टेज माइनस ये वोल्टेज डिवाइडेड बाय द रेजिस्टेंस. So Vx minus 0 upon R1 plus R2 is this current. Gm VGS is this current. So Ix is Gm VGS Vx minus 0 R1 plus R2. Is that okay? Current divide. एक करंट इधर गया, एक करंट इधर गया. Sum of those two currents. From here I calculate VGS value, which is R2 upon R1 plus R2 times Vx. So I solve Ix, I get Ix, and from there I can get Vx by Ix. So essentially what I am saying, that will be also R1 plus, I will come back to correct values, but just see what value I am saying. R1 plus R2 upon 1 plus Gm R2 is the expression I got for R out. Is that correct? From substituting I get Vx and Ix relationship, so I find out that. From here what is that you are again seeing, that the output resistance, if the open loop gain is very high, if Gm is infinite, how much is RO? If Gm is infinite, how much is the value of R out? 0. So large, okay, the accurate value may come, but divided will always come 1 plus GMR. If Gm is infinity or very high, then the R out will keep going lower and lower values. Is that correct? Is that clear? If the gain, open loop gain is very high, GMs are very high, R out will keep falling as the gain increases. Is that correct? So one of the requirement of OPAMP was what? That the R out should be very low. RI is very high, already said वो VGS ही लगा हुआ है उधर, open circuit है वहाँ पर, okay. RI is high, R out is low, and how much is the gain I am talking? Very large open loop gains. Is that correct? So by connecting OPAMP in the networks the way I have connected, which is a negative feedback connection, I am ensuring you that open loop gain is higher if then the output resistance is low and input resistance is high. Is that correct? This is essentially accurate value, you can still get it. The point, yes. All that I am saying that I must somehow guarantee to you is much higher open loop gains. Okay, I think this is not correct. Okay. Now, once I say it, then I can write his equivalent circuit very easily. Please remember what is the equivalent circuit I am now saying. A typical OPAMP, I am now saying if there is my input voltage, I say there is no current inside minus terminal. Why do I say so? Or no current in the V plus terminal. Why do I say so? I can say so, okay, I will come back to it. This is my input, no current entering OPAMP. At the output there is a voltage source which is V1 minus V2 times minus A, and what is this A? Open loop gain. Please remember this is like a DFAM stage followed by a single stage followed by buffer. Minus AOL, V1 minus V2 is your V0. Is that correct? I am assuming R0 very low and I am removing it. In voltage source where R0 will appear? In a voltage source where resistance appears, series or parallel? Series. Since the R out is 0 or very small, this resistance is treated as 0. So this is my output terminal. The voltage which is appearing at the output is minus AOL times V1 minus V2. All that I said, no current enters minus or plus terminals. Okay. Now we will prove this. Why did I say so? Okay. If you see this amplifier once, okay, let us do this first. If you do this, if Ri is infinity, what does infinity means? Essentially a open circuit, but really there is nothing called infinity. So that means there will be a very large resistance connection between this and this, is that correct? So how much will be current? V minus minus V plus divided by R. What is the current in this Ri? V1 minus V2 by Ri is the current in IRI, is that okay? Current in this voltage minus this voltage divided by the resistance in this. If Ri is very high, how much is IRI? Extremely small or less than nanoamps, less than nanoamps, is that clear to you? If that is very small, we may say, or practically 0, we may say this potential must be equal to this potential. When the current does not flow, what is the potential at the two end of any resistor? Same, that is why we say no current. So we may say now, if this difference potential is V minus V plus, the output is AV V minus V plus, which is VD, and if Ri is very large, no current flows through this, means V minus must be equal to V plus. I repeat, is that clear? Why V minus is V plus? Because if we declare that Ri is very high, no current flows, okay, practically no current. That means the voltage difference between V minus and V plus must be extremely small, close to 0. So we say V minus must be equal to V plus. That is why in OPAMP we keep saying V minus is same as V plus. We can see the same thing little differently again. We have a V minus V plus separate into AV is the output, is that correct? That just now from this circuit, AV into VD is the output. So VD is V0 by AV, is that correct? Or V minus V plus is equal to V0 by AV. If AV tends to infinity, how much is VD? VD tends to 0. So V minus of V plus tends to 0. So V minus is equal to V plus. So either way if you look at it, why this is either way coming? Because in deriving this circuit I assumed Ri infinite anyway, that is why I derived this. Okay, so it is not two different things, but it is essentially saying both ways you see V minus will be equal to V plus in an OPAMP circuit, provided the open loop gain is extremely high, and therefore how much gain you expect at least should have 10 to the power 4 and above, or preferably 10 to the power 5 and above, okay, that is the reason. Now let us say if I ground the V plus terminal, I physically ground this terminal, then according to me the potential at V minus is how much? What is the definition of a ground? If the current sinks at that potential, then it is ground, sinks, current must sink there, यहाँ पर current ground पे जा रहा है, so we say it is physically grounded there, इसलिए potential 0 किया, वहाँ सब current sink हो गया. However, in the OPAMP we said there is no really current flowing at V minus. However, these potentials are same, because we say V plus is V minus. V plus are physically grounded, so V minus has a 0 potential, but there is no current sinking there, is that correct? I said V plus is V minus, V plus I made it 0 volt physically by grounding, so V minus I am saying has a potential 0, okay. However, that does not allow current to get in, we said it actually, which means though the potential is 0, no current sink is going on, is that correct? Such a ground is called virtual ground, is that correct? Why it is called virtual? Because current does not sink there, is that clear to you? Current does not sink there, otherwise it is ground, but it is not actual ground, it is virtual ground. The difference is clear to you, difference between actual ground and virtual ground. The potential is 0, one sinks the current, other does not sink the current, is that correct? Though potentials are same there. This is very interesting and that makes OPAMP circuit solving easiest, because once I make V plus 0, this terminal immediately I say at 0 potential, is that clear? Once I make it 0 potential, this current, to solve that becomes extremely simple, is that correct? So this fact that the virtual ground exists only when DFAM has very high open loop gain and the input resistance is close to infinite. Under these conditions we say, OPAMP can say V minus can be created as virtual ground. Now here is a case which I must tell you what happens. This is very interesting case, this is question asked by many people in many interviews to many places including industry if you join, okay. If this is your Vn and this is your V0, if you say this is at ground potential and actually show me like this, तो इसका मतलब तो ये हो गया ये टर्मिनल कहाँ गया, ग्राउंड, ये Vin तो अभी आपको यहाँ मिला ही नहीं, is that clear to you? So this is a potential divider where center terminal is grounded, is that correct? तो ये V0 का इसका कोई रिलेशन ही नहीं रहेगा, यदि ये फिजिकली ग्राउंड कर दिया मैंने तो ये R1 टर्मिनल के बाहर हो गया, तो ये OPAMP यदि वहां से निकाल लिया और इस टर्मिनल को ग्राउंड दिखा दिया, इसका मतलब क्या है, इसको तो निकाल ही सकते हैं हम आपकी थ्योरी के अनुसार, V0 इज माइनस R2 बाय R1 इंटू Vn, पर अभी तो क्या होगा कि Vn ही निकल जाएगा यदि इसको निकाल लिया तो। Only when I put an OPAMP there which has those two properties, then I may say this is at virtual ground and the current is same here, is that correct? This fact must be understood that OPAMP's presence is a necessary to create a virtual ground and it is not a sinking ground, is that correct? By putting this becoming a sinking ground, is that correct? तो ये जो V माइनस है इसको ग्राउंड मत कर देना क्योंकि फिर तो आउटपुट इनपुट से ब्लॉक हो जाएगा. So this is an essential feature we ask that इसका क्या, we always show ask this question, अरे यदि ये ग्राउंड है तो इसको निकाल ही लेते हैं ना, फिर इसकी क्या जरूरत है, फिर यदि OPAMP को हटा लिया तो भी आपका ग्राउंड तो दिया, पर ऐसा किया तो एम्पलीफायर एक्शन चला गया उसमें से, ओके. एंड एज सून एज आई रिमूव AL infinite and RI infinite case, this is a divider which has no input then, okay, and that means this will not act like a system which you are looking for. Is that point clear? So please do not consider that this is physical ground, this is only virtual ground. Once I say it is zero potential, that's enough for me, I am not saying it is sinking any current. Is that point clear? Once I have in my mind, now I can say another net before I quit. No, there are a few more networks we can solve. Okay, here is ये R2 अभी बार बार जो मैं दिखा रहा हूँ यहाँ पर. From here, can you tell me if I want to increase the gain or output voltage, not gain, output voltage, what should I increase? R2. Either I should make R1 very small or make R2 very large, okay. So larger the R2, larger is the gain, I know very well now from there. But then कितना R2 लगा सकते हैं? Typically RI is let's say of 1 mega ohm, okay. समझो R2 10 mega ohm लगा दिया तो चलेगा क्या? नहीं, आप सोचो ऐसा, या 100 mega ohm लगा, आपको तो रेशियो चाहिए है, आप तो वोल्टेज बढ़ाना चाहते हैं तो आप R2 बढ़ाते जाइए, 100 मेगा ओम कर दीजिए तो 10⁶ गेन मिल सकता है आपको, ओके. अब ये सवाल है कि R2 कितना बढ़ाया जाए. तो एक कंडीशन जो आप प्रूव कर सकते हैं, मैं भी कर सकता हूँ, आप करके देखिए कि इट शुड नॉट एक्सीड और एटलीस्ट नॉट इक्वल टू, इट शुड बी ऑलवेज लेस देन द RI अवेलेबल टू यू. दैट इज द कंडीशन यू मस्ट डू. दिस इज वन रिक्वायरमेंट. There is another requirement. Please look at it, the real theory is what we go. As long as the ratio is what you adjust, the gain can be same. I can have 100k and 10k for a game of 10 ohm and 1 ohm also I can have 10. So should I use 1 ohm 10 ohm, 1k 10k, 1 mega ohm 10 mega, क्या values रखना चाहिए, किस पे dependent है? Okay, it does not cross Ri, that much I fixed. What values I should choose and what it depends on? R2 by R1 तो ratio same रखा मैंने. 10 ohm by 1 ohm is 10, 100 ohm by 10 ohm is 10, 1 kilo ohm by 100 ohm is 10, 1 mega ohm by 100k is also 10. क्या values रखना चाहिए? As soon as I reduce the current, I actually reduce the power dissipation. Is that clear to you? So the choice of values of resistances are decided by the maximum minimum currents provided to you in the logbook. इससे ज़्यादा currents draw मत करिए. Okay? इसके अनुसार ही R चॉइस कर सकते. ऐसा नहीं है, रेशियो तो आप किसके भी ले सकते हैं, 0.1 ohm और 1 ohm भी लगा सकते हैं, तो करंट तो बहुत ह्यूज हो जाएंगे. Is that correct? So one has to accept, but too high, what is the problem? I say the feedback problems will start then. RI के पास नहीं आना है आपको. Is that clear? So some way, if you want to improve gains, you will require R2 to be higher, but you don't want R2 to be too high. Is that correct? So what do I do? Here is the solution. Okay. You replace your R2 by a T network. Is that clear to you? What is my problem? Why I don't want to increase larger gain के लिए R2 नहीं बढ़ाना चाहता? Because if I increase R2, it will come very close to Ri. Then I don't want that to happen. So I said fine. अभी क्या करें? एक T network डाल दिया मैंने. Even now, since it's a good OPAMP, I1 is equal to I2 because V minus, because I put V plus as a ground equal to physically ground, V minus is a virtual ground. So the current starting from input will be same as current in the resistor R2, this network. Is that clear? Let us say current in this circuit is I2, R2 में ये थोड़ा सा एरो मैंने ऊपर लिया है, ऑटोमेटिकली साइंस करेक्ट हो जाएंगी V by I करते समय. Okay. This potential I declare as Vx. This is V0, this is Vx, this is how much? ये कितना वोल्ट है यहाँ? 0 वर्चुअल ग्राउंड है वहाँ पर, और ये Vin है. इसमें से करंट जो फ्लो हो रहा है R3 है, ये सॉरी ये I3 है, यहाँ I4 है और यहाँ I2 है. T नेटवर्क है ये. इज दैट ओके? I2, I4 एंड I3. However, I1 must be same as I2. यहाँ से निकलने वाला करंट इस ब्रांच में वही होगा. ओके, because we already said virtual ground is created. No current, also please remember, no current enters OPAMP input. This is the reason why this is all possible. Okay. Now ये potential कितना होगा? Let's look at this potential. Vx 0, please look at it, 0 minus Vx divided by R2 is I2, or we can say I2 R2 is Vx with a minus sign. Is that correct? 0 minus Vx divided by R2 is I2, so minus I2 R2 is Vx. Kirchhoff law, दो नोड के बीच में voltage difference divided by resistance is the current. Is that correct? This potential minus this potential divided by R2 is I2. So minus I2 R2 is Vx. However, we say I2 is equal to I1. I2 is equal to I1 हमारा OPAMP requirement है. So ये I2 R2 is minus I1 R2. But how much is I1? Because of the virtual ground, Vin minus 0 divided by R1 is the I1. So Vin by R1 into R2 is my Vx. Is that okay? Vx is minus Vin by R1 into R2. Now we say at this node Vx, I2 is I2 plus I4 is I3. ये करंट मस्ट बी ये करंट. इस नोड पर सम किया सबको, Is that okay? I am summing current at node Vx. Entering current is I2, entering current is I4, leaving current is I3. Okay. Now you say why opposite? It does not matter, I will put minus sign correspondingly anyway. Okay. So I say I2 plus I4 is I3, but how much is I2? I just now calculated. How much is I2? पर I2 यहाँ से कितना है? Vx by R2. Is that correct? How much is I4? Resistance इसका नंबर ये 4 है, हाँ सॉरी, ये ऐसा साइन लिया है पर माइनस ले लिया है मैंने. इज दैट ओके? आई एम अपोजिट करंट है ना, तो Vx बाय R4 इज IR4, पर उसका साइन माइनस लेके इसलिए माइनस लिख दिया मैंने. माइनस Vx बाय R4 is equal to Vx minus V0 by R3 is the I3 current. Sum of the two currents at the node is equal to the third current. Okay. ये माइनस साइन देख लिया ना, आपको उल्टा साइन लिया था तो यहाँ भी माइनस ले लिया मैंने करस्पॉन्डिंग. ये Vx by R ऐसा करंट था इसलिए माइनस ले लिया मैंने उसको. ठीक है. So this is equal to this. I have collected Vx terms from all of that. So I get Vx is equal to 1 upon R2 plus 1 upon R3 plus 1 upon R4 is V0 by R3. But how much is Vx? अभी कितना निकाला था मैंने Vx? माइनस Vin by R1 टाइम्स R2 निकाला है ना Vx, वो उसको सब्स्टिट्यूट कर दिया मैंने. दिस इज माई Vx. So minus Vin by R1 into R2 into 1 upon R2 plus R3 plus R4 is V0 by R3. Is that okay? इक्वेशन में से सब्स्टिट्यूशन किया जा रहा है. फाइनली इसके अनुसार मैंने V0 by Vn निकाला. V0 by Vn निकाला. So that is minus R2 by R1 into 1 plus R3 by R4, R3 by R2. Now can you see if I did not have T network, तो गेन कहाँ से बढ़ा था मैं? R2 से बढ़ा था. अब मेरे पास कितनी टर्म मिली और? मेरे पास R3 और R4 टर्म्स और हैं मेरे पास. तो मैं इनकी वैल्यू एडजस्ट कर सकता हूँ रेशो में, जो कि ज़्यादा नहीं होंगी, और वो एडिशनल ट्वाइस थ्राइस 10 टाइम्स. ये तो इनिशियल है आपके पास R2 by R1. नाउ इसकी वैल्यू को भी मैं एडजस्ट करके गेन को बढ़ा सकता हूँ. इज दैट पॉइंट क्लियर? व्हाट डिड आई से? इफ दिस टर्म वुड नॉट हैव बीन देयर, दिस इज अ नॉर्मल amplifier R2 by R1, and if I want larger gain R2 I would have increased. Now I said don't increase R2, okay, but adjust R3, R4, R3, R2 ratios, which may not be very high, okay, resistance may not be very high, and still boost the voltage gain. Is that clear? So now is that point clear? Many times the limitation may come on your resistor values. Is that correct? Then don't say sir अब मैं gain कैसे बढ़ाऊँ. नहीं, ट्रिक्स हैं. एक ट्रिक दिखाई, इसकी और भी ट्रिक्स हैं. आप आइडिया लगाओ कि ऐसे नेटवर्क क्यों बनाए गए थे नेटवर्क थ्योरी में. When we are teaching network theory, T network, pi network, everything, you are not very keen. We are only solving there. So मैंने आज आपको दिखाया कि नहीं वो T network कहाँ हमारे फायदे में आ सकता था. I just showed you. Is that clear? This is how you actually play the games. Okay. So this essentially does whatever most of you have already done, but not in this format. I am sure this was not the format. Before we quit, let's quickly see by same logic a inverting amplifier. पहले देखा, अभी what is inverting means? Minus R2 by R1 is a phase shift of 180 degrees, so we say inverting. If I apply a input at the V plus, okay, and still we assume Ri is infinity and AOL is high, V minus is still V plus, so ये V in है तो ये भी V in ही है. Then I calculate current I1, I calculate current I2, so I2 is V in minus V0 by R2, I2 is equal to V0 by I1, so V in by R1, please remember this is V in. फिर से देखो ये V in है तो ये भी V in है. Is that clear? So ये I1 कितना है? कितना I1 है? 0 minus V in by R1 is the I1. वही लिखा है मैंने, माइनस वी इन बाय R1 is V in minus V0 by R2, they are equal currents, same current flowing both sides. Solve किया तो V0 by V in is 1 plus R2 by R1, plus sign आया, so it is called non-inverting gain, non-inverting amplifier. V0 V in are plus, now 1 plus R2 by R1. If I want a non-inverting amplifier with a gain of 100, what should be ratio of R2 by R1? 99, don't say 100, okay, it's 99, is that clear? So correspondingly you must adjust the values, but if it is the inverting amplifier, then what should be the ratio, or what should be the value? 100, because it's minus R2 by R1, is that clear? So there is slight difference in ratios when we do inverting and non-inverting amplifier. A last circuit, there is a non-inverting amplifier with R1 not present and R2 also not present, okay. I am connecting V minus to the output, okay, there is no R1, there is no R2, I am just connecting V minus to the output and then apply input at the V plus terminal, okay. Now you can see V0 is V minus, same terminal hai, but V minus is V plus, so V0 is V in, because V plus is V in, so V0 by V in is 1, is that correct? So V0 is V in, what is this circuit I say called? Voltage follower or a buffer, voltage follower or a buffer. Now this second word why I wrote or buffer, buffer की एक quality होती है, what is the quality of a buffer? That the input resistance and output resistance can be matched to any input side to output side, that is the buffer part, is that clear? What is buffer means? इसका एक रेजिस्टेंस बहुत ज़्यादा या बहुत कम है और दूसरा बहुत ज़्यादा या बहुत कम है उधर में, तो दोनों को बीच में बफर करते हैं, इसको इससे मैच करते हैं, इसको इससे मैच करते हैं, दैट्स द बफर रिक्वायरमेंट. नाउ लेट्स टेक ए केस व्हाई बफर्स आर रिक्वायर्ड. आई हैव ए सेंसर लाइक ए मैकेनिकल का आदमी है जो का स्ट्रेन गेज है, उसका रेजिस्टेंस बहुत ज़्यादा रहता है 100 की. If you have a strain gauge which creates a voltage of say V in with a series resistance of 100k and it has to be sent to a load of 1k, ये नॉर्मल सर्किट है, ये सेंसर का V0 V in 100k का सीरीज में है, इसको आउटपुट पर 1k का लोड को ड्राइव करना है, तो V0 by V in कितना होगा 1k upon 100 1k, तो कितना मिला आपको एक्चुअली 0.01 V in मिला. तो पहले ही V in छोटा रहता है, सेंसर का आउटपुट बहुत छोटा रहता है, ओके. अब तो आउटपुट पे कितना मिला 100 टाइम लेस मिला, इज दैट क्लियर? सो तो आपको कुछ फायदा ही नहीं हुआ, आपको लगाया कि फिर तो आप कभी ड्राइव कर ही नहीं सकते आगे, तो इसका मतलब कुछ तो गड़बड़ हो गया है. नहीं, व्हाट डज दैट मीन? दिस हैज स्टार्टेड लोडिंग, दिस इज कॉल्ड लोडिंग इफेक्ट. If I have a small resistance here which has a large series resistance, तो actually इसके आने वाला वोल्टेज तो इनपुट से भी कम हो गया, okay? At least it should have crossed the input if nothing else, वो भी नहीं मिला मुझे. So I don't like such connections. So I said ठीक है, इसके बीच में एक सर्किट डाल देता हूँ मैं, बफर करता हूँ, ये इससे मैच कर जाए और ये इससे मैच कर जाए, इसका इनपुट इसके साथ मैच करे, इसका आउटपुट इसके साथ मैच करे इस सर्किट का. ऐसा यदि मैंने कर दिया तो दिस विल नॉट लोड द अदर सर्किट, इनपुट विल नॉट बी लोडेड बाय द आउटपुट. दैट्स व्हाई यू नीड ए वर्ड बफर, इज दैट करेक्ट? सो किसी भी इंस्ट्रूमेंटेशन एम्पलीफायर्स के साथ में पहला स्टेज क्या होगा? बफर स्टेज होगा कि सेंसर अननोन रहते हैं, उनके रेजिस्टेंस बहुत ज़्यादा वेरिएबल रहते हैं. ईसीजी लिया, जो मीटर है जहाँ से सोर्स आप प्रोब ले रहे हैं उसका 1 मेगा ओम तक रेजिस्टेंस आ सकता है, क्योंकि ये तो शॉक मार सकता है, बहुत रेजिस्टेंस हाई रखते हैं ना. सच आउटपुट तो ईसीजी दिखेगा ही नहीं आपको कुछ. तो यू हैव टू अंडरस्टैंड व्हाई वी डू ऑल दिस गेम्स, बिकॉज इन रियलिटी वी डोंट कनेक्ट अदरवाइज. सो हियर इज समथिंग आई से, ठीक है, एक वोल्टेज फॉलोअर लगा देता हूं मैं, एक 100 के ये है, यहां आने वाला आउटपुट सेम होना चाहिए, एटलीस्ट उतना तो भी मिलना चाहिए मुझे. अब कंडीशन क्या होना चाहिए इसके लिए, इसका इनपुट रेजिस्टेंस जो है कितना होना चाहिए, एटलीस्ट 100 के से ज़्यादा होना चाहिए, तो लोड नहीं करेगा वो। यदि ये रेजिस्टेंस 1 मेगा ओम से ज़्यादा है तो ये इसका करंट इसके साथ मैच, नथिंग विल एंटर इन दैट, सो ओनली वोल्टेज विल अपीयर हियर, दैट इज फॉलोड एट द आउटपुट. Is that correct? If this resistance is very very high, which is what OPAMP will provide you, this will only create a voltage which is proportional, no current passing, so no drop here. Is that correct? No current passing in 100K, so this voltage appears here, it is followed as it is at the output, and it does not worry what resistance you are putting at the output. Is that correct? This is buffered it. So why buffers? Is that clear? Buffers are essential part in any unknown sources, okay. Otherwise, like antenna of a mobile, okay, it has a 75 ohm balloons as we call, okay, internally antennas. अब बाकी सर्किट 50 ओम पे रहता है, okay. उसको एक ट्रांसफॉर्म करके आना पड़ता है, उसको बोलते हैं बलून, जो इसको इससे मैच कर देता है. Everywhere you need some kind of an amplifier whose input should get protected from the output. Is that clear? Here 1K does not affect now 100K side circuit, because this has very large resistance, allow all of it to appear here, and as follower all that will come out. Is that clear? So अभी आपको इसके across full Vin मिल गया आपको. Is that clear? Now if you wish you can further boost it by R2 by R1 if you need. The first stage must be a voltage follower. Is that okay? Thank you for the day.